Time is an exceptionally intricate idea, with a multitude of definitions and perspectives that are impossible for us to fully grasp. A person's existence is quantified by time, the evolution of everything is gauged by time, and even the creation and demise of the universe itself are calculated using time. Humanity has constantly sought to define, comprehend, and above all, control time. This desire to seize and manage time is perhaps most clearly demonstrated by our unending preoccupation with time travel. The bond between humans and time, which might seem limited, is in fact boundless and profound. Hello viewers, this is a video on the philosophy and physics of time travel. Setting aside the innumerable concepts and portrayals of time in cinema, we require a more grounded subject for our discussion. To start, it can be stated that time is not uniform across all circumstances. Our perception, understanding, and categorization of time will vary depending on the viewpoint of each individual and field. We'll begin by distinguishing between different types of time. First, we have time from a scientific perspective. Put simply, scientific time is the division of time into consistent intervals using clocks as a measuring instrument. It has no color and lacks attributes like bright or dark, winter or summer, spring or fall. Whether one is in prison or free in the world, time passes unrecoverably, without pause or waiting. It is assumed to be identical for all people, and humanity cannot influence or alter it in any way. Scientific time is merely the cold, impersonal, and automatic succession of events. Nevertheless, if people wish to participate in time, there is another category: physiological time. This type of time is, to a certain extent, influenced by humans and can be referred to as growth time. While it is still limited and does not extend into the realm of consciousness, it does contain a human essence. As such, it distorts and stretches according to the individual, their age, and even their mood. Physiological time is most pronounced in youth, since the body in old age has almost no significant development. For instance, a wound on a 5-year-old child will heal more quickly than a wound on a 50-year-old person. One level above physiological time, and related to human consciousness, is psychological time. Psychological time is measured by feelings, emotions, and impressions. Depending on the situation, people perceive time as either brief or lengthy. When we are young, we feel time passes very fast because we are constantly encountering new things and having many joyful experiences. We are swept up in the current of society with countless facts, relationships, and tasks that need to be dealt with in a single day. It's no wonder people say, "One day in prison feels like 1,000 years outside." When freedom is lost, time can feel endless. These are the most fundamental and genuine notions of time. That, however, is not sufficient. To capture and govern time, we need to delve into a profound study of it. This investigation must certainly come from philosophy, the discipline of all sciences. There are many differing schools of thought on the concept of time in philosophy. Most reflections on time stem from Western philosophy, whereas Eastern philosophies present little on the subject. Most of the most prominent Western figures have discussed time as a serious and essential topic for in-depth research. Sometime between 544 and 583 BCE, the renowned ancient Western philosopher Heraclitus made a very famous statement that we continue to repeat to this day. Heraclitus came from an aristocratic family in Ionia, but he had to live a poor and difficult life. In Heraclitus's view, all things in our world are in constant change, motion, and development. The world is like a river that perpetually flows. Based on this perspective, the argument, "No one steps into the same river twice," was born. Everything is in flux. These changes occur in succession, both opposing and giving rise to one another, similar to light and dark, hot and cold, day and night. Nothing is as stable as a river, yet nothing is as ceaselessly in motion as a river. The moment it is still is also the moment it is changing. Time possesses a quality of movement and is never motionless. Not everyone, however, agrees with this. Most notably, Parmenides, a representative philosopher, asserted that existence is eternal and all change is merely an external illusion. Following this line of thought, the philosopher Plato believed that in addition to the changing phenomenal world, there is a world of ideas, of the soul, a world that is eternal, unchanging, and beyond time. In other words, there are worlds unaffected by time. Time, then, naturally becomes the moving image of an unmoving eternity. Over 200 years later, around 300 BCE, new schools of thought began to emerge. For the philosopher Aristotle, the fundamental nature of the universe is change. He defined the philosophy of nature as the study of changing things. Accordingly, time is the measure of motion, based on before and after. Time is continuous because it belongs to continuity, and only the present moment is truly time. We then witnessed the emergence of a renowned philosophical school known as Stoicism. It conveys the idea that contentment is one of the most valuable elements in life. A quiet, peaceful, and calm life is found through self-restraint, which includes the ability to master one's desires and oneself, and not indulge in lust. According to the Stoics, time has no true substance, but all non-existence and movement occur within time. Time is present in the life of the world, meaning creation, because the universe is nature and creation itself. Therefore, the sage Epictetus, a representative Stoic philosopher, advised us to follow and embrace time, to live in accordance with it, and to be in harmony with creation. So, what about modern philosophy? In the latter half of the 17th century, we have Gottfried Wilhelm Leibniz, a polymath who played a significant role in European politics. In philosophy, he is best remembered for his optimism. Leibniz argued that time, like space, is completely relative and has no substance. He conceptualized space as the order of things that can exist together, while time is the order of things that can succeed one another but are related. This poses a difficult issue regarding time. How can we explain its dual nature, being both successive and continuous, both distinct and yet encompassing the moments that form it? In summary, time is not one but two things. It is both an objective, overarching natural law and a subjective human concept. Only humans are aware of time. Humans are the only creatures who know they will die, and that time is constantly passing, so people must have time with existing things. In Buddhism, when addressing the issue of time and aspects related to the world, the Buddha often taught that with limited insight and a mind full of delusions, humans cannot fully comprehend the origin of the universe. Humans can only understand in general that the formation and destruction of the world occur over many different long periods. The time of each life in each realm also depends on the collective karma of the beings in that realm. The Buddha taught his disciples not to seek the past and not to wish for much in the future. The present is the most magical and meaningful moment for the flourishing of each person's life. Living in the present is a way of life that the wise have experienced and reminded future generations of. By dwelling in this way of life, humans will realize the unity between themselves and others, between people and all things. From there, they will accept that the self is only a distant, faint shadow, and that their existence always depends on the existence of others and countless other causes and conditions. These are the most prominent things that humanity knows about time through a philosophical lens. So, what about humanity's dream of grasping and controlling time? What have we done to make it a reality? Philosophy may not be the wisest path. We need a different path, and physics may give us that. The modern understanding of time and causality mostly originates from Einstein's theory of general relativity. He combined space and time into one, creating the concept of space-time, which explains the mechanisms of both in an extremely complex and subtle way. It has been over 100 years since the theory of general relativity was born and experimentally verified with extremely high accuracy, so physicists believe that general relativity is the key to accurately describing the causal structure of the universe. For many decades, people have tried to use general relativity to analyze whether time travel is possible. Some of the equations they came up with show that time travel is completely compatible with the theory of relativity. However, physics must still rely on the foundation of mathematics. These equations would be meaningless if they did not correspond to real things. Time travel is the notion of motion that is believed to transport a person or another object from one point in time to another. It is understood in the same way as movement between different points in space and is carried out by a theoretical invention called a time machine. The motion can occur from the present back to the past or forward to the future. Time travel is a category recognized in philosophy and science fiction novels. It has more or less support from theoretical physics, often from the theory of quantum mechanics, string theory, or wormholes. To be fair, traveling to the future is much easier than traveling to the past. There is no general consensus on which written work represents an example of ancient time travel stories, as some works only contain vague elements suggesting time travel. Ancient legends and folklore often only include a few details similar to the main character's journey to the future. For example, the Hindu epic Mahabharata mentions the story of King Ravita. He went to heaven to meet the god Brahma and was shocked to return to Earth, realizing that many years had passed. Basically, there are currently three most common ways to travel to the future: hibernating and waking up in the future, the simplest way. The second is to travel at an extremely high speed, according to the theory of relativity, where the elderly will be younger than their actual age because the time they experience is shorter than the time humans on Earth experience. Did you know that when we travel between continents by plane, we are also time traveling but with a very small time difference? Third, we can get close to the event horizon of a black hole, because the closer we get to a black hole, the greater the gravity, causing time to slow down. In the movie Interstellar, near the black hole, only a few hours pass, but 23 years pass for the outside frame of reference. So what is the feasibility of each option? Are they really useful? With the first method, which is also the most feasible, we can put ourselves into a state of near inactivity, then wait for technology to develop, and wake up. In the world today, there are actually people who are hibernating like that, but that is not time travel at all. Basically, time still passes. The third method is too unfeasible compared to current technology. Thousands of years of scientific development have only brought us to the moon. So how many more years will it take for a person to get out of the solar system, let alone get close to a black hole? So, we will focus most on option 2. For example, we have an experiment that takes a very, very long time to get results, say 10,000 years. Assuming time travel technology exists, we would put that experiment on a spaceship that travels almost as fast as the speed of light, then wait for it to return to Earth and get the results. If this idea is successful, it would not only help us solve the problem of waiting for experimental results, but could also be all solvable problems depending on the speed of the spaceship. However, there are difficulties with this approach. The biggest problem is the need for a lot of energy to accelerate. Currently, There is no technology to create a vehicle that exceeds the speed of light, because we have not yet had any breakthrough to escape from Einstein's legendary equation EXMCL2. An existing object will have an inverse relationship between three quantities: energy, speed, and mass. The mass of an object with mass increases with velocity. An object with the speed of light will have an infinitely large mass. For a spaceship to reach the speed of light, its mass must be equal to half the Earth. We are certainly not capable of manufacturing such a thing. To increase the velocity of a mass to reach the speed of light, either a finite acceleration over an infinite time or an infinite acceleration over a finite time is required. Both of these ways require an infinite amount of energy that we have not yet found a way to create. Only massless particles have reached the speed of light. Photons, things with mass, can only get close to the speed of light. But we can do it if we solve the problem by creating a matter with negative energy. Still according to the equation EXMCL2, to create negative energy matter means that its mass must be negative, because the speed of light is always constant. Quantum mechanics tells us that, in theory, it is possible to create negative energy matter in extremely small quantities and for extremely short periods of time. At the same time, there is no evidence that we are completely unable to create negative energy. Not only that, we can find equations that allow time travel without borrowing these substances. Therefore, this problem lies only in our current technical status or our limited understanding of quantum mechanics. Traveling to the future sounds so difficult and distant. The most notable part must be this: traveling back to the past, because it is truly a difficult problem to solve, both in practice and in theory. If we consider time as a linear flow according to Newton, time travel is basically like a train running on a track. When the flow of time passes, it leaves a trail behind it. So is it possible to go back along these tracks? Because it's simply a matter of you opening the train door and jumping out of the train, then walking back in the direction of the tracks. But the hypothesis is, are you sure you won't slip off the tracks? Unlike in reality, the timeline here is invisible and colorless. You can feel it, but you can't draw it accurately. Therefore, if you jump out of the time train, how sure are you that you know which way to go back? It's very easy to deviate from the tracks and fall into a state of infinity. Even if you succeed in returning to the past, you are not sure you can return to the present. How can you follow the time train when it is being left far behind? You run for 1 second, the time train also runs for 1 more second. Therefore, the time traveler may be stuck in the past. But nothing is impossible. Just as long as the travel device has enough speed to break the time limit, everything will be completely different. The most interesting part of traveling to the past is here. That is the paradoxes that will arise if we go to the past. The most famous and difficult to solve is the grandfather paradox. The grandfather paradox is a problem in the paradox of time travel, simply understood as an unsolvable or inexplicable problem. It was first described by science fiction writer René Barjavel in the work Le Voyageur Imprudent, published in 1943. However, similar problems have been described earlier. A typical example is the novel By His Bootstraps by Robert A. Heinlein. A man travels back in time and kills his grandfather before his grandfather marries his grandmother. As a result, his father will not be born. That leads to the man never being born. So how could he travel back in time? But if he doesn't go back in time to kill his grandfather, then his grandfather must be alive, and that means he is still born and can time travel to kill his grandfather. The two situations above negate the existence of both cases. This is a kind of logical paradox. Although the name of this theory is the grandfather paradox, it does not specifically refer to the impossibility of a person's birth. Rather, the concept includes any actions that make it impossible to time travel back to the past from the beginning. The name grandfather paradox is the most common name used to describe the phenomenon of the time travel paradox. Another example is when we use the scientific knowledge of scientist A to create a time machine, then use it to go back in time and kill scientist A. If scientist A is killed before inventing that scientific knowledge, then the time machine will not exist. And when it doesn't exist, how can we go back in time and kill the scientist? A vicious circle of causes and effects repeats itself. This leads us to the next paradox of traveling to the past, called the predestination paradox. The predestination paradox, or causal loop, is a time travel paradox often used in science fiction works. A causal loop consists of Event 1, which occurs first, being the cause, or at least one of the causes, of Event 2, which occurs later. And by time travel, Event 2 is again the cause of Event 1. The paradox occurs when the time traveler falls into a loop of predetermined events. When a person time travels to the past, Event 2 will be the event of the time traveler returning to the past, and Event 1 is something the time traveler did in the past that made that person want to return to the past to fix. This paradox hypothesizes that time travelers have no way of changing an event. For example, when a person goes back in time to save someone from a car accident, and when in the past, that person takes a car and drives to the place before the accident occurs, accidentally hitting the very person they came back to save and causing the death that made them in the future want to return to the past. This theory is closely related to the ontological paradox, in that there is something whose cause cannot be determined, which in this case is the reason for the time travel. The paradox does not imply that there is a larger plan from a higher origin. It only asserts that time is immutable. Time travel is always a destiny. A series of events can still happen by causality rather than by a supernatural origin. Similar to the predestination paradox, we have the bootstrap paradox. Because an object or a piece of information from the future is sent back to the past, it will affect the existence of that information or object. It is described with an example as follows. You go back in time and hum a song by your favorite singer, and that singer hears it and comes up with that new song. So who created the song? Not you or the singer. The bootstrap paradox always creates a mystery about the origin of information in many novels and movies with time travel. To make time travel a feasible task, we must solve the paradoxes. A common misconception in science fiction is that paradoxes can be created. Time travelers are often warned not to change too much from the past and not to repeat their past. An example of this is found in many time travel movies, such as the Back to the Future trilogy. But in physics, a paradox is not actually an event that can really happen, but a purely theoretical concept used to refer to the contradictions of the theory itself. In other words, the self-consistency paradox not only implies that time travel is a dangerous act, it also implies that it may be completely impossible. This is one of the motivations for the chronological protection conjecture of theoretical physicist Stephen Hawking. Hawking believed that time travel was impossible. He also conducted a simple experiment to prove his point. He wrote an invitation detailing the location and time of a party he was hosting and sent it thousands of years into the future to invite future people to come back to his party. But how to send that letter to future people thousands of years later? It turns out it's very simple. Put the invitation in a sturdy metal box, then bury it in the ground. Thousands of years later, future people will dig it up. They will know the location of the party and his GPS position on the timeline. If there was a machine that could travel back in time, future people would definitely come to Hawking's party, because after all, he is a theoretical physicist with enough credibility with humanity. Unfortunately, Hawking waited all day, and no future people came to his party. These conjectures are still not enough to convince other scientists. Instead of ruling out time travel because of the paradox, we can eliminate the paradox itself, and the universe will be much more interesting. To solve the time travel paradox, theoretical physicist Igor Dmitrievich Novikov proposed the self-consistency conjecture. The basic idea of this theory is that you can travel to the past, but you cannot change the past. Novikov points out that if you go back 5 minutes and try to destroy the time machine, you will find that it is completely impossible to do so, because the laws of physics will try to intervene and protect self-consistency from being destroyed. Applied to Hawking's case, you can time travel to the past, but you cannot change the past in any way. Even your appearance in front of Hawking at the party is impossible. Physics always has a way to maintain consistency with the history it has created. Therefore, if you can actually travel to the past, you will probably only exist there as an observer, like a person who only has view rights in a Google Docs file, but not editing rights. But what's the use of time travel if you can't change the past? At least it allows us to confirm history. If you can't change history, at least you know what really happened and can verify whether what historians have recorded is correct or not. However, even the self-consistency principle cannot solve all paradoxes. Instead, this man has proposed a more plausible theory. He is Barak Shoshani in Canada. Time travel in which there are multiple histories and we can actually change one of them. In other words, Shoshani's idea is similar to what we see in Marvel movies, that there are multiple timelines existing in parallel at the same time. This can solve any time travel paradox, including the grandfather paradox. Shoshani says that when you exit the time machine, you will fall into a different timeline, not your own. In that timeline, you can do anything you want, including killing your grandfather without changing anything in your original timeline. Because your grandfather in your main timeline is still alive, your father will still be born, and so will you. There will be no paradox here. For many years, Shoshani has studied the time travel paradox. He is now increasingly convinced that time travel is completely possible, but only if our universe allows the existence of multiple timelines. So the question is, can there be multiple timelines in the universe? From a quantum mechanics perspective, the answer seems to be yes. But these are just conjectures. O'Connell is currently still looking for a time travel theory that combines multiple histories and is fully compatible with general relativity. Of course, even if they find such a theory, it will not be enough to prove that time travel is possible. But this at least means that time travel is not completely ruled out by the self-consistency paradox. Time travel and parallel timelines always appear together in science fiction, but researchers have proven that they are inseparable in the real world. General relativity and quantum mechanics tell us that time travel is possible, and thus humans have every right to dream, and even seriously pursue the idea of building a time machine. Then it is exactly a machine that jumps between different timelines and universes. You know, the present will also become the past. So we don't need to go back to the past to change that future. Change something now so that in the future you don't have to wish you had a time machine anymore. That is what it truly means to control time.